Hello everyone, I am Dr. Sirajul Akfaisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about transition state. So what is the transition state? You know the transition state are highly unstable in which only partial bond are present, not full. Due to instability, transition state cannot be isolated. In transition state, all bonds are formed or all bonds are broken, due to which transition state is unstable. You can see the reactant A2 and B2 and the product. So breaking of AA and BB, and now you can see the bond break, this bond break, and the formation of new AB bond. So we can say that transition state unstable non-isolate compound formed as a bond or broken admit. Now leave it the history. You know the Hammond postulate. Hammond postulate, or alternatively Hammond's Leffler postulate, is a hypothesis in physical organic chemistry which describes the geometric structure of transition state in an organic chemical reaction. Hammond postulate states that a transition state of a reaction resembles the structure of the species reactant or product, to which it is closer in energy. So you can see the exothermic reaction. You know that this is the exothermic reactions. You know the endothermic reaction. This graph is endothermic. Now some applications of Hammond postulates easily explain the relationship between the rate of reaction and stability of the product. Applications on electrophilic addition reaction, which proceed through the formations of carbocation and formed by the protonation of an alkene in an endergonic state. Explain the selectivity of product forming during bromination and chlorination of alkane. Useful in rationalizing the SN1 mechanism of alkyl halide, which proceed through the formation of carbocation as an intermediate. Now you can see the application of Hammond postulate to the SN1 reactions, the more stable transition state and less stable transition state. So less stable carbocation and more stable carbocation, slow reaction and fast reaction. Now predicting the mechanism of nucleophilic substitution reaction. 4 factors relevant in the predicting whether given reaction is likely to proceed by SN1 or SN2. Alkyl halide, nucleophile, strong or weak, leaving groups, and solvent, protic or aprotic. Now nature of the alkyl groups. You can see the increasing rate of SN2 reaction and increasing rate of SN1 reactions. Now vinyl aryl halide, SN1 and SN2 reaction occur on sp3 hybridized carbon. Vinyl aryl halide, which have a halogen attached to sp2 hybridized carbon, do not undergo SN1 or SN2 reaction. Heterolysis of the CX bond would form a highly unstable vinyl or aryl cation. You can see the vinyl halide and phenyl halide or aryl halide, sp hybridized. Now effect of the nucleophile. The strong nucleophile, which usually bear a negative charge, present in high concentration, favor SN2 reaction. Weak nucleophiles such as H2O and ROH favor SN1 reaction by decreasing the rate of any competing SN2 reaction. Consider what happens when 2-degree alkyl halide, which can react by either mechanism, is treated with a strong nucleophile HO- or weak nucleophile H2O. So cis 1-bromo-4-methyl cyclohexane, a strong nucleophile and weak nucleophile. Now effect of leaving group. You can see the better leaving group increase the rate of both SN1 and SN2 reaction. So better leaving group is more stable to accept negative charge. Now effect of solvent. Polar protic solvent like H2 and ROH favor SN1 reaction because the ionic intermediate, both cation and anion, are stabilized by solvation. And polar aprotic solvent favor SN2 reaction because nucleophiles are not well solvated and therefore are more nucleophile. So limitation of Hammond postulate. Hammond postulate makes a connections between rate kinetics and equilibrium thermodynamics that has no theoretical basis. Use of Hammond postulate is based primarily on enthalpy consideration and neglect the effect that activation entropies can have on reaction rate. And the Bronsted catalysis law and empirical linear free energy relationship is valid within carefully chosen group or acid or bases. So thank you.